Good morning, all. Thank you for joining us today. We'll wait for more 5 minutes and then we'll start the webinar. Hello, all. Welcome to the webinar Optimizing Data Efficiency with AWS Strategic Approaches, hosted by Cloud.in. I'm Mayuri Deshmukh, currently working as a sales representative at Cloud.in. For today's session, we have Ashwini Giri as a speaker who will guide us how we can help you optimize data efficiency with AWS. Ashwini is working as a sales manager at Cloud.in. Before starting the session, I would like to mention a few points. All attendees are muted by default and cannot be unmuted during the session. We'll have a question and answer sessions at the end of the presentation. If in case you have a question in between the session, please raise your hand to grab speaker's attention, or also ask a question through the question section. I request Ashwini to start the session.
Great. Thank you, Mayuri, and good morning, everyone who has joined today. As Mayuri said, I work with the Cloud.n as a sales manager, and today we are covering a topic which is just like the name suggests. It says optimizing data efficiency with AWS, and we'll try to talk about strategic approaches here. But then again, at the same time, this is not a small topic at all. This is a huge topic. We can talk about it for 3 days maybe continuously. But a small session for an hour will definitely give you a quick idea and overview into the importance of data and how you can manage the data and why it is important, stuff like that. This webinar is purely non-technical, so anybody who's like me, who doesn't come from a technical background, it will be easy to understand presentation. And like I said, this is I did not want to mislead anyone with the topic in itself or the information that I have presented in this presentation. But like I said, data is a huge topic, and I'm trying to just cover the bit of it, and I'm keeping it non-technical purely. Anyway, so moving on to the next slide. If Suvarna could please move on to the next slide. So basically, before we start, before I jump into the actual content, I wanted to talk about a bit that who we are and why such topic. Why are we uh, capable of speaking out of such topic and helping the clients? What makes us the gives us the power to, or gives us the knowledge to talk about such topic, like who we are basically. So we are cloud.in, and we are a 23-year-old old firm, and we have thousands of customers. We started off as a domain registrar. um, in the cloud journey, I think it's been seven plus years ever since that we have working with the cloud partners such as AWS, and currently we are recognized as an advanced consulting partner for AWS as well. We have got dozens of competencies as well, which I would show in the later slides as well. So let me just make it quick in the introduction part, so we get to the main topic as soon as possible. I'm sure you guys are waiting for it. So moving on to the next slide, please, Suvarna. Okay, so this talks about the growth, that how we have grown. As I mentioned, that we are a 23-year-old firm. We are now 50 plus team. We have two locations, well, actually three now, because I'm in New Delhi, so I would like to count that as well as a third location. Apart from the New Delhi, we have locations. We are headquartered in Pune, and the second location will be Mumbai. We have 50 plus cloud certifications, 200 plus live workloads, and 6,000 plus endpoint protected. I believe that these are not the up-to-date numbers. Pardon me on that. I apologize. But then these are, I would say, most recent, if not the latest ones. So I think it's a fair bit of information to provide. Moving on to the next slide, please, Suvarna. All right. So as I mentioned that we are partnered with AWS, as you can see in this slide, but we are also partners with Google Cloud, Microsoft Azure, and in terms of security, we are also part of a Checkpoint, Fortinet, and then in the bottom you can also see VMware, Druva, and Confluent as well. So this is just a few names that we are partnered with and we are working with. Moving on to the next slide, please. Okay, these are our offerings. I don't want to take much time in this, but basically it's managed services and cloud consultancy and advisory. We also have expertise in migration. So if you want to migrate your workload to any of the cloud providers, then we can help you do that. Then application services as well, and managed services. And in the earlier slide, you might have seen that we also provide 24/7 monitoring as well, so NOC support. These are some of our offerings that we are really proud of. Moving on to the next slide, please. And these are our competencies, as I was talking about, that we have almost a dozen of competencies that includes, and that is from an AWS perspective. So that includes WAF delivery, Lambda configuration, RTS, CloudFront, education services competencies, well-architected partner program, Microsoft workload services competencies, and cloud formation delivery. I think there are, again, like I said, that I don't think that I have added the latest information in it. But yeah, these are the most recent certifications. I think there are a couple of more competencies that we have recently um, got, and I missed out on putting those names here. But yeah, this is good enough for now. So these are our competencies. Moving on to the next slide, please. So when we can move on to the next slide, please. Okay, okay. Now this is what we were waiting for, and when I was writing this presentation, when I was creating this presentation, the one thing that I have had in mind that how can we define data? What is data? In simplest term, you can see the definition of the data, and basically anything that we do today leaves a footprint. Any activities that we have on the internet, or for example, when we are ordering from Amazon, what are we watching on Netflix, when we are paying bills, and when we are delaying paying our bills, or when we are crossing a road by paying a toll tax. So these are the activities that we are constantly involved in, and we are leaving a footprint, as I like to call it, and that takes a form of a data. So when we are ordering something from Amazon, and it creates the history and what we have ordered, so that Amazon can come up with a suggestion of something similar next time, because they are now using the same data, or the item that we have ordered. Now they are utilizing that information to push their sales, to give us more. So I think that's what I like to explain when it comes to data. But then definitely in the presentation as well, you can see the specific example definition of it. It says data refers to raw facts, figures, or information that can be collected, stored, and processed. It is a representation of facts, observations, measurements, or descriptions about something. In the context of computer and technology, data can take various forms such as text, numbers, images, audio, video, and more. Now, as we are super active on internet these days, it is understandable that how much data, how much footprint we are leaving behind, and for the companies, how difficult it is becoming for the companies to handle that data, and not only just handle that data, but handle it in a good way, so that they can utilize it, and they can possibly make their next marketing move, when they're thinking about the company and how they can make their customers happy. So basically that's what they want to utilize. They want to utilize everything that they already have the knowledge. And where are they getting the knowledge from? They're getting the knowledge from the customer's footprint, the behavior of the customer, which is pretty much evident with the activities of each of their customers on the internet today, whether it's their phone or a laptop or computer, because everything is online now. So it's pretty understandable that the data market, or the data analytics market, is estimated to reach around 346 more than 346 billion dollars by 2030. Like in the next 6 years, that's the size of the data analytics market that we are talking about. That's the size that we are talking about in terms of the how much data we are receiving. So I think this is how I like to explain what data is. But yeah, moving on to the next slide now, Suvarna, please. So, data can be collected, as I mentioned, that it's basically the footprints of your activities on the internet, or whatever you do on the internet. It takes a form of a data. Um, but, like, how would you define, what would you say that how data is being collected? So there are few ways that how data is being collected. That's how I've mentioned actually. I mean, there could be hundreds of ways how data is being collected, but I just had to fill the slide. because I had to mention that how data is being collected. This should be this is an important information. So transaction records, as I mentioned, and cookies, internet cookies. You may have seen visiting a website, and it just immediately asks you to accept cookies before you proceed on the website. So that is another way of collecting data, visiting websites, social media tracking, keyword tracking as well. So their SEO comes in. These are the data which kind of by default gets collected. But then apart from that, there are other activities that businesses take part in order to collect data for any specific campaign that they are about to run or they are interested in running. And those could be loyalty programs or customer forms, surveys, service agreement, competition. So these are some of the ways how they like to collect more data, versus which already they are collecting from the basic methodologies. Um, so now, it is pretty clear that every day the data is being collected. Every second, I would say, a plethora of data is being collected, and it's all about the company that how they like to use it. So basically, I like to share an example in here as well. When I mentioned about Amazon, and when you're ordering something from Amazon, and maybe you purchase an item, so they would, like, let's say for example, you bought a television from Amazon, and then Amazon understand that you already bought a TV. So what goes along with the TV? Then along with the TV goes the TV stand, or along with the TV goes the speakers, or maybe a switchboard, or maybe a couch, right? So these are the information that they are just generating because you have ordered a TV. So they're pretty good at it. That's how they're pushing their sales strategies or marketing strategies. But then companies these days do not really utilize the data as much as they could. They can I was reading somewhere that data is like diamond, and you just have to figure it out first. So for example, I also have an internet connection, my internet provider. So I was having difficulties last year, and I complained to them like multiple times about my internet services, as it was disrupting my work day. So I made several complaints, and every now and then somebody was visiting, and then they're trying to fix it. It would be fixed for a couple of hours, and then the same thing was happening. So on one side, I have made a complaint which was going on and on for weeks. And then on the other side, I received a phone call from the same internet service provider that if I want to upgrade. So that does not make sense at all. So that is a poor communication among the team first, and that is also a poor usage of the data. That is clearly showing that I'm not happy with the services in the first place. So I may not be the right prospect for them for upselling. I may have appreciated their confidence and ended up upgrading the services, but that would be just once one odd scenarios. Traditionally, it does not really happen that way. You need to make sure that your clients are happy, and you need to understand the behavior of the client, and that's how you can proceed. So I think data tells every story, like whatever you want to find out. Uh, with that, I just wanted to share, of course, the example, and then with the collection, the data collection, as we are on the screen right now, I was also reading somewhere that we expect the data universe to grow more than 10 times from 2020 to 2030. Like in 10 years, 10 times more, reaching 660 zettabytes. I'm not even sure if that's a word, but it's zettabytes, equivalent to 610 iPhones, 128 GB per person. So that's kind of crazy. Like 600 iPhones worth of data being that will be collected in just the next 10 years. So I think solving data is the need of the hour, and this should be done as quickly as possible, and businesses need to understand how important it is. So since we are on this topic, and I've just mentioned that the businesses, need to kind of understand how to solve it and what they can do with the data. So, what are the challenges that they're coming up with? Like, why they're not doing it? There must be some challenges. Let's just talk about those challenges for a bit. So, moving on to the next slide, please, Suvarna. Great. So, if you ask any business today that what are the challenges they're facing or they have faced uh, in respect of with respect of to data, they might have various problem statements. They might say so many things, or they may have so many statements to make about the problems of their data. Yet, these are they revolve around the three V's. So let's discuss the three V's. What are the three V's and how they are becoming a challenge? Okay, first, don't get confused with the term big data. It's nothing but data. There is no specified volume. When one refers a data to a big data, like so don't get confused with that data or big data. For now, let's keep them as same terminology. So basically, three V's defines the challenges of a big data, which actually is a challenge of a data as well. In other words, so the first V that we're going to talk about here is the volume. And as the definition is pretty clear, volume is like the size. So let me highlight once again that since the data is being collected in a vast amount, it is becoming difficult for businesses to hold on to them as they are running out of spaces so quickly. And it is important to understand what data is a good data, and that can be uh, done with the and what data you want to keep. That's also very important. Getting rid of the data is also very important, or at least archiving them is very important as well. So it doesn't really keep your cost up all the time just because you want to hold on to the data. And on this slide, it says that the constant feeding of information is piling up so fast and becoming so large that storing and processing it requires advanced technologies. Um, so that's the first challenge. Like, what would you do with so much of data? How are you gonna solve it? It's it's so much. It's a plethora of data. So that's one challenge. Now, the second challenge talks about the velocity. So again, just like the name suggests, uh, this talks about not the size of the data, but how fast the data is being collected. And it has been analyzed in real time. It has to be analyzed in real time as well, which has been a challenge for many businesses. So especially for IoTs, with IoT devices, the data is constantly being kind of recorded, and then data is on a very fast speed as well. Like one example or two that I can think of when it comes to the velocity or the speed of the data, with the speed that is coming in is an ECG machine, right? The ECG machine uh, needs an instant cardiac monitoring, and it needs to process that information instantly. Other one could be, I'm not sure if would be the right example, but yeah, I think live sports could be another example when they have to analyze the fair play of the game. So that could be another example of the speed or the velocity of the data. Um, and like it says that a lot of data comes from sources such as website analytics or IoT sensors, which can generate many data points. Okay, so that's the speed or the velocity of the data. Now the third one comes in, and that is variety. So data can come in many formats that can be structured as well as unstructured. Now, uh, Life would have been much easier if the data came in just one form. But it does not. It does not come in just one form. Data can come in so many form because data is not just coming from one source. There are so many sources that generates data. For example, data can be generated by a machine, and then data can also be generated by human. Um, for example, humans can write free form text, images, uh, documents such as PDF, audio recordings, videos, voicemails, um, and then there can be other information as well, such as when you're processing an order, there is an order ID being generated. That's also a form of data. But these are two separate kind of data. What are those kinds? We're going to talk about. But let's just quickly go through it. Data can come in many formats that can be structured as well as unstructured. There is a third kind as well, which is semi-structured. But I don't think we have to get there, because structured or unstructured, once we have understood, we would understand what semi structure could mean. Now, um, so let's just discuss the last one first. Let's just talk about the variety first. So since we are on the topic of structured or unstructured, so what if we could please move on to the next slide? Great. Okay. Now, the structured data, let's just go through the definitions first. Structured data is highly organized and formatted in a specific way, typically within a relational database. It follows a well-defined data model, which clear and fixed with clear and fixed rules for how data is stored, accessed, and manipulated. So there's a term in this definition is a relational database. I don't want to get to the exact definition of it, but just to give you an idea of what relation database, an example of relation database can be is let's say you're filling out a form online, and there is a column that asks for your phone number. As soon as you enter a phone number, it accepts it. But if the number of the the digits on the number is more than 10, which usually cannot in India, um, it won't accept it. But as soon, or it wouldn't accept any alphabets either. You cannot put an A or your first name initial before the phone number. It wouldn't just accept it, because that form or that page is made for the collection of those digits only. Hence, the data which it will collect, it will be in a decided format, a format that is pre-decided, that is how the data needs to be collected. Hence, it becomes easier for the businesses or the system to kind of segregate it or kind of structure it. So I think that's what a structured data would be. And unstructured would be just the opposite of that. But by definition, it says unstructured data lacks a predefined data model and does not fit neatly into tables or databases. It is often more freeform and may include text, images, videos, audio files, and other formats without a specific organizational structure. So one example that I could think of it is basically when you are, let's say, you bought a product from Amazon, and that product came broken, and you have to explain back to Amazon that why you're not satisfied with the product. So you may click pictures of the product, and then you may also write a free form, text or complaint to Amazon, which was not predefined. The texture of the complaint was not predefined. Hence, whatever information that you're putting it now would be an unstructured data for Amazon, right? So that will be an example of an unstructured data. And semi-structured, like I said, once you have understood these two, you would know, semi-structured is like something in between the structured and the unstructured ones. So I think another example of unstructured data could be, again, I'm not sure if this could be the right example, but I believe CCTV cameras and the footage of the cameras are generally unstructured as well. Uh, so variety can be a major challenge for businesses to get insights from, especially in an unstructured environment. And now, in terms of how AWS is solving problem of data, not only that, how it is going beyond finding insights, um, but also how it is making the life a little easier. Um, so we're gonna talk about again. What I have tried to do here is that we spoke about three challenges or three V's of the data, the challenges of the data, but I try to come up with a solution, or not necessarily solution, but the services of the AWS which are making life easier in terms of data. I've tried to categorize them. They are not necessarily can be used in the same category, but then this is just to create a presentation. And as I mentioned that this is a vast topic, I'm trying to kind of put everything in line, which is kind of difficult to do. Yet I'm trying to present some of the services of the AWS, and how we can get rid of these challenges we just spoke about. So moving on to the next slide, please, Savarna. Okay, right. So the first challenge that we spoke about was the volume, right? So as soon as I hear the keyword volume, immediately the service that comes in my mind and how to resolve that that comes in my mind is Amazon S3. So you can see about S3, and what is it about on the slide itself. Um, but then one of the features that I love the most about S3 is that they have the data lifecycle management as well. So as I was talking about the volume and how to get rid of the data as quickly as possible, to not accrue any more cost. Uh, Data lifecycle management in S3 gives you, let's say for example, you are running an e-commerce website, and then you are selling a product which uh, and the guarantee of that product only lasts for 60 days. Um, so since you cannot accept any returns of a product more than after 60 days, you really don't need the data of that item or related to that item. I'm just giving a hypothetical example here. So maybe after 60 days you do not want that data to be ruining your storage anymore. So you may want to get rid of it, but still for your own records, you may still want to keep it. So with the data management or data lifecycle management in Amazon S3, you have the ability to either kind of predefine rules, and those will be whether you want to keep the data after 60 days, or you want to put it in you want to put it in archival, or you want to get that deleted. It's totally up to you. So that's how you want to manage it. So one of the major challenges that it is solving is the volume. And then when you are putting it in an archival, you're not paying you literally paying negligible cost on, if I talk about in terms of GBs. So per GB you're paying very little amount, even if you want to stick to that data, or you can simply just get that deleted in every 3 months or every 6 months. I mean, you can define your own rules. So that's one of the best thing that I like about S3. And well, S3, when you're using Amazon S3, well, any of the Amazon services, and these are some of the common features which we're going to talk about later. But then with S3 as well, it seamlessly can integrate with any other AWS services as well, which just makes the whole system kind of perfect as well at the same time. I don't want to go through the statements that are written in here because I think I have pretty much explained what S3 is. These are definitely good to know though. Like the last one with Amazon S3, it's designed for 99 point, I think 99%, 11 nines, okay, it says, of durability, and the stores data for millions of customers all around the world. So it kind of telling you that it never shuts down. It is so reliable. Um, and so I think that's all I'm going to talk about. When it comes to volume, remember S3. You can also use DynamoDB, but that would have been a little more complex to explain. And since I'm trying to keep it as simple as possible, I did not want to go through DynamoDB. Instead, I chose Amazon S3, which is a great service in itself. So moving on to the next slide, and let's look into the velocity now. So can we move on to the next slide, please, Suvarna? Thank you. Great. Now, when it comes to velocity, as I mentioned earlier, that velocity is the speed, how quickly the data is being collected. Now, there are a couple of services that I have mentioned. I have mentioned Amazon Athena, Kinesis, and then AWS Glue as well. So let's go through the definitions of each very quickly. And again, this is the layman definition that I have found from the internet. So imagine you have a super smart librarian in the cloud. The librarian is excellent at finding information in a huge library, but there's no need for you to organize the books in a specific way. You can just walk in, ask a question, and get the answer you need instantly. Isn't it great? So basically, Amazon Athena is an interactive query service provided by Amazon Web Services that enables you to analyze data stored in Amazon S3, and that will be using standard SQL queries. And SQL queries are basically queries that will be run that can be run for the structured data in a structured data environment. Mostly that's what it happens. It can also be used in a semi structured environment as well, but Amazon Athena is a great tool in order to finding or analyzing data, and you really don't have to, like it says in the example as well, that you really don't have to manage it, or how do you want to keep it. As long as it's connected through the S3, it will just fetch the information for you. Wherein Kinesis is a great tool. I think this is one of the best tools that I like about Amazon AWS, or the AWS services. So in terms of data, basically, let's just go through the definition first. Again, a layman terms definition would be that if you imagine you have a giant funnel collecting a river of data from different sources like social media, website clicks, or sensors, AWS Kinesis is like a set of tools that helps you manage and process that river of data in real time. So basically, Kinesis is not just one single, I don't know how to say it, but it's not just one single thing, or a single uh, power that kind of helps you define the data. It's kind of set of computers, set of servers that it kind of helps you to figure out. And there are again three different kinds of Kinesis. So for example, the first one would be Amazon Kinesis data streams. Kinesis data streams is a core service for building real-time data streaming application, and it allows you to ingest and process large volumes of data in real time, dividing it into shards that can be processed concurrently. So it's not only just processing the data as soon as it receives it, it also kind of categorizing the data as well. And then you can probably run it simultaneously, depending upon how the system or how you wanted them to be categorized. And applications can read and write data to Kinesis data streams using the Kinesis API or the AWS SDKs or software development kits. And then the second one comes in as Kinesis Data Firehose. Firehose simplifies the process of loading streaming data into AWS stores and analytics services. It basically works great when it comes to live sports or a live concert or live environment of video streaming, because then you are constantly receiving data, and then it automatically scales to match the volume and throughput of incoming data and can deliver data to destinations such as Amazon S3, Amazon Redshift, or Amazon Elasticsearch without requiring custom code. So that's data firehose. Then you also have data analytics and then video streams as well. And these are four categories or the four subsets. I wouldn't say subsets, but then four kinds of Kinesis services that you could use for four different um, um, problems to solve, which is amazing. And Kinesis is like basically a set of uh, tools that you put to work for you, and you just define the rules and they will do the thing for you. They will just do the magic for you. So I think this is one of the best services in terms of data when it comes to Amazon Kinesis, and um, when you're trying to sort out data. Now there would be this third service in on this slide is when we are talking about velocity. I would also like to name AWS Glue. It's pretty interesting service, I must say. But then, just to give you a layman terms of definition, it says, imagine you have a magical assistant named Glue. Glue's job is to help you organize and clean up a big, messy pile of information. That's definitely one thing that Glue does. But then one of the features of AWS Glue is called data crawlers. And what data crawlers does is it automatically discovers and catalog metadata from various data sources, and crawlers can identify the schema and structure of data stored in Amazon S3 database and data warehouse. So crawlers are basically a constant, I would say, feature or service that is of AWS Glue that constantly monitors the data which is coming up with the speed, and then it kind of analyzing the data and kind of categorizing it as well. So that's AWS Glue. This will be the velocity again, and not necessarily it has to go through or solving the velocity issue only. It can be a good fit for maybe variety as well. But since we are kind of short on time here, I'm going to move on to the next slide and quickly take you through the rest of the services that can be used. So Suvarna, if we can please move on to the next slide. All right, so I'm not going to take much time on this one here. So EMR is basically, if you have, you know, it says like if you want to solve a massive jigsaw puzzle and you want to figure out the big picture, but this puzzle is so gigantic that it would take forever for you alone to put all the pieces together. So you have a team taking care of the puzzle in parts and all at the same time. So basically, it's again creating a bigger picture with the smaller resources um, that you want to achieve. And it says you tell EMR what kind of analysis you want to perform on your data, and it takes care of distributing the work among the computers in the cluster. And this way, you can get results much faster than if you were trying to analyze all the data by your own or just with one computer. So moving on to the next service that we have is Amazon QuickSight. Amazon QuickSight is if you it's like having a magical pair of glasses that not only help you see but also analyze and understand the world around you. AWS QuickSight is like those magical glasses, but for the business of the data. Again, I don't want to take much time in here about the Amazon QuickSight. I, it's QuickSight also provides an intuitive and user-friendly interface, making it accessible to broad audience, including business analysts, data scientists, and decision makers. So basically, QuickSight can be used for either technical or non-technical person, both. Um, because it kind of shows the graph. It kind of shows that how the data can look like. So that would be QuickSight, and then we have Aurora, and then Aurora says that imagine you have a magical book where you write down all the important information about your favorite recipes. Now, what if you wanted to share this magical recipe book with your friends and family so that everyone could add their favorite recipes? This is where AWS Aurora comes in. So again, pretty much clear definition, and it talks about how it can be a shared it can create or help the businesses working among the team, so that the teams that who are working on data and getting insights can put their insights as well, and communicate in a more efficient manner. So that will be Amazon Aurora. And there's just one more thing that I want to kind of help you guys, or good to know information rather. So basically, just going back to the EMR, EMR also is known for, or it's a great, it's a popular, to it works great with the popular framework like Apache Spark, Apache Hadoop, or Apache Hive. And these are, uh, don't be confused, or don't get scared by just hitting these words. These are just a frameworks, and they have been developed to kind of solve specific challenges of the business when it comes to data. And then AWS EMR has been made easy to use, and compatible rather, to work with Apache subsets, or the tools that the Apache provides. Apart from these, I also like to highlight that there are some common features, and there could be more, but some of the common features that I have here for, or in any AWS services that so far we have discussed. These are all serverless and managed services. Fully managed services means basically AWS taking care of the administration part of these services. These are reliable and secure services, and these are cost efficient. You only pay what you use, and a great integration with Amazon services. And yeah, you can scale with these services anytime, and as you go about it. So that would be the third service. These are the services that I wanted to highlight because they work really well. But on to the next slide. Suvarna, if you can please move on to the next slide. Great. So these are some of the services that I have taken a screenshot of. These are also some great services. So maybe next time when we talk about data, we also may want to talk about machine learning and how machine learning is really helping sort the data. And then two machine learning services that AWS provides is recognition and SageMaker. And these are really the buzzwords in the market right now, machine learning as it is. But then in this slide, you see the data sources. If you have any difficulty with the data sources, you use any of the services such as Data Exchange, Kinesis, IoT, AWS IoT, or AppFlow. Or if you have any difficulties with the databases, then you use Aurora, DynamoDB, um, RDS, and there are more as well. And then analytics, Athena, you can use intelligence for, you can use QuickSight or EMR. For data lakes, S3 is the only option, or S3 is a great option anyway. And then for catalog or machine learning, I have already mentioned about the machine learning. So these are some of the services that you can read by yourself. Now, finally, there's just the last slide that I want to go to. So, Suvarna, if you can please go to the next slide. Right. So in this slide, I wanted to kind of take one a case study. I wanted to keep it simple, honestly, but then, I really couldn't find anything. But yeah, so I just picked the first one that I saw. So I picked a case study from Nasdaq and AWS. So Nasdaq is basically a multinational financial service and technology corporation that owns and operates the Nasdaq Stock Exchange. Nasdaq operates a total of in 27 markets, and they're also in located in 50 different countries. This is based out of US, by the way, but they also operate in 50 different countries. So see, they have one of their vice president for software engineering. He just mentioned, he talked about AWS, and he says we were able to easily support the jump from 30 billion records to 70 billion records a day. So that's how much data they're receiving, because of the flexibility and scalability of Amazon S3 and Amazon Redshift. So this is how their infrastructure or the architecture looks like. So they have the data sources, it goes to S3, they use EMR, use Amazon EMR to transform and dense the data, and then it goes to S3 again, and then to Redshift, and finally the quick slide to analyze the data. This is just on a high level. Of course, we are not diving deep into the case study exactly what they have, how exactly it was working, as this is purely non-technical. But yeah, I definitely wanted to include one of the case study, one of the names, well-known brands that you guys can relate with. Anyway, so I think this is it. This is all about the data, and like I said, this is a vast topic. We can talk about it for 3 days, continuously, and then still, I don't think will be able to finish the topic. But yeah, this is just my small effort of introducing you to how data can be efficient, and things that we need to take care of, and how we can utilize. So I think this is it. Moving on to the next slide, and it okay, so if you have any questions for me, we have got like 5, 6 minutes more. If not, you can always contact us. As you can see the information down below. You can reach out to us on LinkedIn. You can also reach out or visit our website, which is cloud.in, and it's not mentioned here. Sorry about that. You can also reach out to us on sales at cloud.in, and it should get to me or one of my colleagues. So I think that's about it, and I'm done with the presentation. So if you do not have any questions, we can probably end this webinar. So, Mayuri, over to you, please.
Ashwini, I think we don't have any kind of question in the chat box. We can wrap up the webinar.
All right. Sounds great, Mayuri. So it was pleasure giving this webinar today, and I hope every one of you have a great day ahead. And thank you so very much for joining. Take care of yourselves. Bye bye.
So, bye.